Brian Hammermeister, Exam 2 take-home portion. I'm going to show you my IP address of my local PC, 10.130.46.31. Going to secure shell into my DigitalOcean server to show you the IP of that box. IP address of my DigitalOcean server is 159.89.150.48. I'm going to exit out of secure shell. I'm going to start my Wireshark capture. I've already got my conversation filter built in there, make it easier. You can see no packets are being captured yet. I'm going to go ahead and hit secure FTP back to my DigitalOcean server. See the packets starting. I'm now going to upload a 4 to 6 meg file from my PC to the DigitalOcean server. There it goes. 6%, 94, 100%. I'm going to exit out of my secure FTP. I'm going to stop the Wireshark capture. Look at the sequence numbers, packet 616. I'm going to show you in the packet decode here before I go to the Stevenson's graph. The sequence numbers will go up by the size of the packet 1368. So packet 616, if you look at the next one after the ACK in 617, 618, this goes up sequence number exactly by 1368, the length of the packet. So does 619 goes up by 1368 on the sequence numbers. 620 goes up another 1368 in the amount of the sequence number, and then finally the last one I'm going to show is 621 goes up 1368 in the sequence numbers. But if you look at the Stevenson's graph, I've tried to map that out here closely. It doesn't exactly show like you'd like it to. Here's 616 here. You can see it on the Stevenson's graph. And then as the sequence number goes up, the next one it allows me to show, it jumps to 619, and I assume 618's here, it won't show, it won't highlight it. But the sequence number does go up by 1368 as well. And then you look here, the next one shows 621. The sequence number goes up another 1,368, which is equal to the packet length. And then if you see that, 621. So you can see how it's going up on the Stevenson's graph. The TCP sequence numbers always increase, and as they increase over the period of time of the secure RTP file transfer, the window size increases. I'm showing a picture of the throughput graph in Wireshark. You can see here on the graph as the window size increases, as you go up here, up this scale, you can see the throughput increases. And the window gets really large. It gets 12,000, jumps to 14,000. The actual graph shows calculated window size, which is actually a little bit bigger. You can see here the calculated size is 130,976. I'm showing, if I look at the Wireshark transfer and I look at frame 3650, so frame 3650 right here, if you look at the window size here is 12,460, then it calculates it even bigger. And then if you look at another jump up here, frame 3868, see the window size is now went from 12K to 14K, 14,654. So again, if you go back to the actual throughput graph, that's showing this right here, and the window size is getting bigger, therefore you're getting more throughput. Now, if you look at the RTT, the round trip time, and I've lined this up pretty good, so the time actually lines up here on the 20 on the throughput graph lines up pretty good on the round trip time graph. You can see here, as the packets get larger, not the packets, but as the window gets larger, you can see here the round trip time will tend to go up. Now, you can transfer more data in each round trip time, but the round trip time does go up. You can see it kind of tracks along here with the throughput where you're getting longer RTTs, but you're transferring more data per round trip time. So that's a good thing. Task 6, 7, and 8. I've already configured my packet discard at 5%, where I'm highlighting here. I'm going to start my Wireshark capture. I've already created my IP conversation filter. I'm going to secure FTP into my DigitalOcean server. I'm going to upload the file from my PC to the server, 6%, 100%, all done. I'm going to quit the secure FTP. 6. Before I go to the Stephenson's graph, I just wanted to illustrate what I was looking at in the packet decode here. Frame 5474 is acknowledgement for frame 5473. This is where my problem starts. As I see 3 TCP duplicate ACKs trying to ACK for 5474, and as I look through here, the first duplicate ACK is 5598 right here, and then you see 5611 is the second duplicate ACK, and then finally 5638 is the third duplicate ACK for packet 5474 where my cursor is pointing. And then finally the server sends on 5639 a TCP fast retransmission, and I'm going to show that on the Stephenson's graph now. The duplicate ACKs are going on right here on this first sequence numbers all going up. Get right here, this is 5636, and then right after that 5638 is in here as well. Well, that's when right after 5638, 5639 is the TCP fast retransmit, and you can sequence number goes back down because it takes on the ACK number of packet 5638, and that's why the sequence numbers change for this one. For task 7, I'm showing the throughput graph. If you look at my mouse where I'm highlighting, roughly right here is where first duplicate ACK happens, packet 5598. Right over here, roughly here at the bottom of this corner, is the second duplicate ACK, packet 5611. And you can see we're kind of stalling out on the throughput as this is going on. And then finally, if I pan down a little bit here, this is right around here is packet 5638, which is my third duplicate ACK. And then and so you can see the throughputs, it just keeps dropping as I hit my third duplicate ACK. And then if you look right here where you get this little dip, this is actually packet 5639. This is the server to the my PC for a TCP fast retransmission, where it shows a real quick dip in packet throughput. So I did draw a correlation here between the server with packet loss and the duplicate ACKs, and finally the fast retransmission. For task 8, I'm now showing the round trip time. I'm on the same packets, so right here where I'm pointing with my mouse is roughly where the first TCP duplicate ACK was transmitted. And you can see it's 5596, so it's somewhere in there, just past that to the right. And then as you move up, you can see 5610 here. So mine was 5611 was a second TCP duplicate ACK. And then finally, as you move up here, 5637 is right before my third duplicate ACK, which was packet 5638. And then finally, this last one here, 5639, is my fast retransmission. So you do see the round trip time increasing from where I started here at the bottom where my cursor, my mouse is, and finally where the retransmission occurs up here. The round trip time does go up a little bit